right, today we'll be looking at lesson 7. We live in a three-dimensional world called space. We can measure the length, width, and depth of objects that occupy the space around us. When we are looking at drawing something on paper, we are looking at a two-dimensional world. That would be a plane. So a flat piece of paper is like a plane. It has length and width, but there's no depth to it. Occupants of a two-dimensional world could not pass over or under other objects because there's no depth, and so there's no over or under. It doesn't exist. A one-dimensional world is a line. It has length, but it doesn't even have width or depth. So in a one-dimensional world, you could not pass over, under, or to either side of an object. You can only go back and forth on a line. Geometry is the study of figures that have one dimension, two dimensions, or three dimensions. So we have to define some terms for geometry. A point is an exact location in space, and it is so small we cannot measure its length or width. So it's a location. It has no length, width, or depth. It's a point. We will label it with a capital letter. A line, there's an artist called Paul Klee, and he said, a line is a dot that went for a walk. So a line is an infinite number of points extending in opposite directions without end. A line has one-dimensional length. It has no thickness and no depth. I'm going to put 1D, one dimension. We represent a line by sketching part of a line with two arrowheads. We put the arrows on there because this line goes on in either direction. We will then put points on the line and label our points, and then we can say that this is line AB. We could also say that it's line BA because it really doesn't matter which direction we come from when we're labeling the line. A ray is part of a line with one endpoint. In other words, it's going to go forever in one direction, but it's going to stop in the other direction. So here's an end point, and then here it goes on in one direction. So we would label this ray CD. And this one, it does matter which direction we read it. We are going to read it from the end point letter to the point that goes on past. So we can put ray CD, or we might just put CD and put the little ray symbol over it. With our line, we might put the AB and put our line symbol over it. A segment is part of a line with two endpoints. So if we took line AB and just took out the infinite parts on either end and said we just have this much of it, this would be segment AB. And I would draw the line over the segment, but without the arrows. It's not a line, it's a segment. It has an endpoint on either side. It could also be segment BA. The ray makes a difference which direction we name it because you're telling us which one the endpoint is and which point it goes past. For segments or lines, since it's the same either end or not end in either direction, you can label them either direction. A segment has a specific length. We may refer to the length of the segment by writing MAB. So that would be the measure of AB. It refers to the distance between A and B. So if this was exactly 1 inch, we would say the measure of AB is equal to 1 inch. A plane is a flat surface that extends without end. It's two-dimensional. It has length and width. A desktop is part of a plane. A piece of paper is part of a plane. A big poster board would be part of a plane. It has no depth, but it goes long and wide. Two lines in the same plane either cross once or do not cross at all. So in the same plane, the lines will cross or they won't cross. If they cross, we say that they intersect at one point. So these two lines here and here, they intersect at one point. So this would be their point of intersection. If two lines in a plane do not intersect, then they have to be the same distance apart forever and ever. They would be called parallel lines. So if this line is next to this line and they're the exact same distance apart all the way, so this distance is the same as this distance is the same as this distance, then they are never going to cross. Imagine like two rail lines. The railroad ties are in between, but the lines have to be the same distance apart so that that train doesn't have to grow in width along the tracks. So those two rail lines where the tracks are, those would be parallel lines. They will never intersect. Now, if the lines intersect and they form square corners, then we call them perpendicular lines. So if these lines intersect and we find that that's exactly a square corner, these would be perpendicular lines. Lines in a plane that are neither parallel nor perpendicular are called oblique. So these are oblique lines. They intersected, but they weren't exactly perpendicular. An angle is formed by two rays that have a common endpoint. So if I have a ray right here, and then the common endpoint means that I have to have another ray that starts in the same dot and maybe goes over here. Then now I have formed an angle. This is the vertex of the angle. It's the common endpoint. And then the rays coming off of them are going to be the sides of the angle. We name the angle by stating a point on one ray, the vertex, and a point on the other ray. So this could be angle GUM. We can also name it the other way. This could also be angle MUG. But either way, we are going to put the vertex in the middle. So that U always has to be in the middle. Either way we name it. If there's only one angle, there's no chance of confusion. You can skip the points on the ray and just call it angle U. But sometimes we have a lot of angles and maybe even an angle that shares the same vertex. So if this is my picture, then I could not just say angle U because I don't know if I mean this angle or this angle or this angle. So if there's only one angle on the page, that you can maybe just name it from the vertex, but most of the time it's a good idea to go ahead and use the 3 letters to name an angle. We classify angles by their size. So remember when we formed that perfectly square corner in perpendicular lines? That is called a right angle. If it's smaller than a right angle, we call it an acute angle because small things are so cute. If it's bigger than a right angle, we call it an obtuse angle. And if it's a straight line, then we call it a straight angle. The last thing to talk about is that if we have lines that go this direction, they go side to side, exactly side to side, they're not tilted. This is like looking out on the horizon. So this is called a horizontal line. And if it's going straight up and down, then we call it a vertical line. If you've ever seen a power pole, they might look a little bit like this. You got a couple lines there. We have 2 vertical poles, and we have, I'm sorry, those are not vertical. Those are 2 horizontal poles, and then we have 1 up and down, so 1 vertical pole. And we could even say that the angles formed here are square or right angles, so that the vertical pole and the 2 horizontal poles are perpendicular. So the vertical pole and this horizontal pole and the vertical pole and the taller horizontal pole, they are perpendicular.